Hey everyone, my name is Andile and welcome to 2D Questions. Please don't skip this intro as it is very important. This video covers everything that you need to know to get a minimum of 60% and above in this section of the paper. It is very important that you watch the video in order. Why? Because as we move along, we're going to come across some concepts that I've already explained earlier in the section. So I won't be going deep into them again. They've already been broken down properly before. So there is no need to repeat as already I've explained it in a deeper sense. The video breakdown, the video is going to be divided into two sections, which is section 1 is going to be revision from Euclidean, which is very important. Reason for that is that section 2, which is now doing the 2D question, is that the revision that will be doing in the first section is going to help you with answering the questions or understanding the concept properly, which is section 2. So that's how the video breakdown is going to be. This video is pretty long, so to help you out, I've added timestamps in the description. You can use them to jump to specific parts if needed. Again, right? Just very important. Only use it to jump into sections if you already know the fact that the previous sections you already understand. If you don't understand, make sure the fact that you go in order. As I said, the fact that everything is a build up. Hope that makes sense, right? So with that said, we can start with the video.
So now what we're going to talk about triangles. We're going to talk about the different types of triangles that you basically need to know about. Then we're going to move to congruency, and I'm not going to touch similarity now. And the reason is because of the understanding of similarities makes sense when we do grade 12's work. So I'm going to just fuse it with grade 12 because of it just makes sense there because we use it a lot there, right? So let me just change my pen to black. So let's talk about the different types of triangles. So the first three that I think you guys need to truly know is the scalar, is the isosceles, and equilateral, right? So what is a scalar? A scalar is when a triangle, all sides and angles are different, meaning all its angles are different from each other, meaning angle A, it has its own angle. Angle C has its own, and angle B has its own. So it has different angles, and also the sides are different, meaning this side is not equals to this side, is not equals to this side. That's what it means. It means the fact that all sides and all angles are different from each other. They're not equals to each other. So now let's move and talk about an isosceles triangle. An isosceles triangle is that two sides are equal in length. Therefore, that means the fact that the angles opposite are also equal. So it's that if you have a triangle where the two sides are equal like this, then their opposite angles are going to be equal. They love this one. Just keep it in your head. They love using it, right? Then we have what's called an equilateral triangle. What does that mean? It means the fact that all sides are equal to each other, therefore all angles are equal to each other. And the reason why we already know that the angles are going to be equals to what? Are going to be equals to 60 degrees because the sum of triangles. Let me talk about that first. Then we're going to come back to equilateral. Why is it equals to 60? And why do we know that it's 60? So one property about a triangle is that the sum of triangles, right? So let me just highlight it. The sum of triangles is equals to what? Is equals to 180 degrees. So basically when you add up this angle A, as I put it here, and we add up the angle B plus the angle C, it's going to give us what? 180, right? So, and the reason here is going to be sum of angles in a triangle. So that is how we know the fact that this is 60. So let me just emphasize it more so that you can see it visually. And even if when you get to the test and they don't tell us the fact that it's 60, I don't want you guys to memorize this. I just want you to know how we got there, right? It's that we know the fact that the sum of angles is equals to what? Is equals to 180. So we know the fact that angle A plus angle B, right, plus angle C is going to be equals to 160 degrees. But from this thing, what do we know? We know the fact that with equilateral, all angles are equals to each other. So we know the fact that angle A is equals to angle B is equals to angle C. So do you agree the fact that I can replace my B and C by A so that it can be the same variable because they're all equal to each other? So I can say that angle A plus angle A, because I know the fact that A is equals to B, plus again angle A, because I already know that A is equals to C, right? I can say the fact that this is equals to 180. And A, because it's the same variable, it's the same as saying 3A is equals to 180 degrees. Divide both sides by 3, therefore angle A is going to be equals to what? To 60 degrees. But the nice thing is that if A is equals to 60, that means that B is equals to 60 degrees. Angle B is equals to 60 degrees because of what? Because of angle A and B are equals to each other. And therefore, I can say that C is equals to 60 degrees because of angle A and angle C are equals to each other. And also angle B is equals to angle C. So that's how we got to angle A, B, and C equals to 60 degrees because of the sum of angles in a triangle, and that angle A, B, and C are all equals to each other. I hope that made sense. So now, what we're gonna, because I already talked about the sum of angles in a triangle, what we're gonna talk about exterior angles of a triangle. So we're going to talk about exterior angle of a triangle, right? So what does that mean? Is that this exterior angle, which is this one, right, is basically equals to the angle that's outside is equals to the sum of the two, right? So when you add this two up, right, you're basically going to get that. And this is what exterior angles of a triangle. So just remember that. Is that the angle that's outside is equals to the sum of the angles that's inside. So now we're going to move to congruency, right? So before I talk about congruency, you need to basically understand the difference between congruency and similarity, right? So one thing about congruency, it's a sign, is that with congruency, what do we use? We use this 2. And with similarities, we use these 3 lines. So what is the difference between congruency and similarity? Congruency, we're proving that 2 triangles are identical to each other. When I say identical, it's that the angle from one side is equal to the angle of the other side. The side from one triangle is equal to the side of the other triangle. That is congruency. With similarity, it's we proving the fact that if we had this, let me just go down just so that you can see it, is that if we had a triangle like this, right? I'm just explaining the concept of similarity, right? If we had like a big triangle like this, and this triangle, we scale it down like this. This triangle, the small one, is similar to this one. The only difference is that their sides are in proportion. I'm going to talk more about the proportionality, but their angles are going to be identical with each other. Where with similarity is that we have 2 triangles that are equal in everything. So they are equal in length, they are equals in angles. Whereas similarities, they are equal in angles, but they are not equal in length, but their lengths are in proportion. Just know the fact that congruency, we mean the fact that they are identical. Everything is the same. Similarities, they are not identical, they are just similar. That's why the word similarities, their lengths are in proportion. It's just a big triangle. If you create a small one, that is similarities. You have the ratio of the other one. I hope that made sense, right? So with that concept now, what I'm going to focus on, what? On congruency, right? You need to know how to prove congruency and its different rules, right? So we're going to just go through the different rules. So in total, you see the fact that we have 4 rules to prove that something is congruent. And don't worry, I'm going to do an example to basically show you on how you would do this. Anna? So the first one, let me just take my highlight. So the first one is right angle triangle. So I'm not going to read the statement. We're just going to look at the diagram and show you the fact that how you would use that, right? is that to use this one of the things, you see the fact that the reason it says what? It says 90 degrees, hypotenuse, and a side. So in your triangle, you need to have these three properties. You need to have proven these three properties. So you see the fact that the hypotenuse is always the one that's opposite to what? That's opposite to the right angle. So do you see the fact that we already have hypotenuse here, right? That is why this one is satisfied. We have proved the fact that both of them are 90 degrees, which satisfies this one, right? Then an extra side, it could be this side, it could be this side. It really doesn't matter. In our case, they use this side, right? And therefore, you can say the fact that the two triangles, right, are congruent. And the reason is 90 degrees because you proved it. Hypotenuse because we proved it. And what? And a side. That is why it's RHS, or 90 degrees hypotenuse and a side. I hope that made sense. So to say this is the reason it's going to be, after saying the fact that these two triangles are equal to each other, you're going to say your reason is R what? H is. So this part, the rules, is also the reason when you're done proving, right? So after saying the fact that these two triangles are congruent, you're going to say for this one, because we know the fact that we proved the fact that it's 90 degrees, it has an hypotenuse and an extra side, you're going to say RHS, where R represents the 90 degrees because right angle. Remember when we're doing properties of a line, right angle. Then H represents the hypotenuse and S represents the side, right? So that's how you would do it. So to use the reason side is that when you are proving, you find the fact that all the sides, you're proving the fact that the sides here is equals to this side is equals to this side, and this side is equals to this side. So when proving congruency in this case is that you prove the fact that all the sides of both triangles are equals to each other. So therefore, the reason that you're going to use here is, and that just represents side, right? So let's say you get to a question, then you prove the fact that maybe you have two sides and an angle, right? So how would you write this? The reason why the angle is in between is that how the diagram is situated means how you're going to write it, right? See, let me just read the statement. It says, if two sides and an included angle. Very important. You see the fact that it says included angle. So let's say while proving is that you prove two sides, and you see the fact that the other angle that you can prove is the one that's in between the two sides. That is what it means to be an included angle. Included angle is the angle that's inside, or what you call this, is in between the two sides that you've already proved. So do you see the fact that there's two and the angle is in between the two sides? That's what it means to be an included angle. The angle that's in between your sides that you already have. So if you have the case, is that, do you see the fact that this shows this situation? This is a side, and this is a side, and this is an angle. So that is why it's side, angle, side. So your reason here is going to be side, angle, side. Remember the fact that you can only use this one if what? If the angle is in between the two sides. So for instance, let me just change the color. Let's say our angle was here. Do you see the fact that this angle is not the included angle? So you can basically say side, angle. So with this one, you can say side, angle, right? Because this angle is not included. I hope that made sense, right? So with this one, because if you see the fact that both the sides that you have proved and the angle is included, you're going to say side, angle, side, because of the angle is in between the two sides, right? So now moving to the other one is what? Angle, angle, side. Again, the diagram says it all, right? Is that, do you see the fact that we have two angles and a side, right? And on the other side, again, is an angle and a side. Is that since we have this situation going on, do you see the fact that you have two angles and one side? Also here, two angles, because that's what you've proved, and one side. Your reason is just going to be angle, angle, side. So now let's just recap with congruency. Is that this one, I feel like it's very easy to see it. Is that it says it is that you have already proved that the sides are equal. So that is not like necessarily a trace match. It's that side would be your reason, because of when you are proving that sides are equal to each other. But angle too is not like a trace match. It doesn't need you to remember things. It's that if you had two angles that you proved that equals to each other and a side, then it makes sense the fact that your reason will be what? Angle, side. But this one, I just feel like just remember the fact that if you're dealing with right angle triangles, right, and you prove that it's 90 degrees and the hypotenuse and an extra side, just remember the fact that you need to use at HS. And with this one, right, is that just remember the fact that if you prove the fact that two sides are equal and the angle that's included inside, right, that's in between the two sides, just remember the fact that it's side angle side. If it's the other way, as I showed with the red one, is that you can't use this property. So just going back to the right angle triangle, right? So let me just go back to the right angle triangle. Let's say, for instance, you prove the fact that this is 90 degrees, right? But you prove the fact that the other angles are equal to each other. So you prove the fact that these two angles are equal to each other. Do you see the fact that in our case here, it's not the same as this one? Here we prove that all angles are equal. So you see the fact that here your reason will be angle. So what you've proved determines what you're going to use. We can only use the right hypotenuse and side when you have proved the fact that the hypotenuse are equal to each other. The right angles, which is the 90 degrees, are equal to each other, and an extra side. Just remember the fact that that's the only time you can write that reason. I hope that made sense. So that's the end of triangles. So now let's do an example where I prove that two triangles are congruent. As you can see in the question, it says determine that two triangles are congruent. That is the first part. And the second part, it says use the results to find X, Y, and Z. So let's just look at the diagram and check how we can prove that congruency. How does it exist, right? So in our case is that with proving that something is congruency, you need three statements. Then after having that three statements, then you can say the fact that the two triangles are congruent. So what do we see first? We see the fact that we have a 3 and a 3. That's perfect. So we have one statement. Again, we see the fact that we have 90 degrees here and we have 90 degrees. That's our second statement. Now we need our third statement. So it can go this way. It can go by us finding the unknown of either this one, right? But if we do that, that's us using trigonometry. Or we can find the unknown of y. If we find the unknown of y, we know the fact that it can relate to this one. Because here they give us 35 and here is what is 55. So if this one is 35, that means it's going to match with this one. I feel like that is the easiest way to do it, is to find this value here, right? And that is going to be our third statement. So let's find that value. So we know the fact that the sum of a triangle is what? Is equals to what? Is equals to 180. So we know the fact that in triangle ABC, right? We know the fact that angle A plus, right, angle B plus angle C, right, meaning this one, because I said in triangle ABC, it needs to be equals to 180 degrees, right? What do we have? We already know what angle A, which is 90 degrees, and we have angle B, which is 55 degrees, and we're looking for angle C, and this is equals to 180 degrees. If I take 95 and 55 to the other side, angle C, when let's punch it in the calculator, is going to be 180 minus 90 degrees minus 180 minus 90 degrees and minus 55. What do we get? We get that angle C is equals to 35 degrees. So we know the fact that this one is equals to 35 degrees. And again, this is Euclidean. Remember to put your reasons. So the reason here for angle A, B, and C being equals to 180 is it's sum of angles. That's what I mean. Sum of angles in a triangle. So that's your reason, right? So we know the fact that angle Y, therefore, let me just do this. Therefore, Y is equals to 35 5 degrees. So we already solved one of the unknowns, which is y. So we know the fact that this is 35. So now let's go and prove congruency. Is that you're going to say in both triangles. So you're going to say in triangle ABC and triangle what? Triangle DEC, right? So the first statement is what? Is that we know the fact that angle side AB is equals to what? Is equal to side DE. Remember that they equals to 3. And your reason here is that it's given, because it was already given in the diagram. Then the second statement is what? It's that angle A, right, is equals to angle D. Remember that they equals to 90 degrees. And the reason is what? It's also given, right? Then the third one is what we just proven. Is that angle, I'm just going to name it, is that angle B going from here, coming here, putting a cap here, and going this direction. So angle BC, right, A, is equals to, we want this one now. So it's going from here, coming here, and going this direction. So angle DCE, that equal. And we can see the fact that we have proven that they both equals to 35. So we can say that it was proven. Because remember, we proved it here up, right? So if that's the case, now we have 1, 2, 3 statement. So now we can conclude that what? The triangle ABC, right, is what? Is congruent to triangle DEC. And what is our reason? Do you see the fact that here we have a side and here we have 2 angles? So our reason is going to be, since it's 2 angles, it's going to be angle, angle, then one side, then side. I hope that made sense. So that's how we'll prove congruency. So now we are done proving that this 2 is congruent. So remember the fact that this is the first part. And let me just highlight it in another color. This is the second portion, which is I'm going to name number 2, right? So for number 2, which is I'm going to just do here, right, is that what do we see? We see the fact that they say we need to find the unknown. We already have that y is 35. So since these 2 sides are congruent to each other, do you agree the fact that z needs to be equals to 5 because of that's the hypotenuse? So we know the fact that z is going to be equals to 5. And the reason why is because of that's what? And the reason for that is that the 2 triangles are congruent. So you're going to say because of triangle ABC is congruent to triangle DEC. I hope that makes sense. It's because of, since these 2 triangles are congruent, we can just relate the sides, right? Then, with that said, what's left is angle X. But to find angle X, we need to use what? Theorem of Pythagoras to find it, right? So using theorem of Pythagoras, we know the fact that the hypotenuse, which is this one, which is CD, so in triangle, I'm using this triangle now. Triangle DEC, right? Is that we know the fact that CD, I don't know how I'm going to have space, but let me just take it here. Let me just erase here. I know if you're looking at this, looking at just the notes, you're going to be like, this is a mess. But if you've watched the video, you can understand that I didn't have space. So I'm just going to do number 2 here, right? So what we know, I said the fact that we know the fact that angle Z is going to be equals to what? 2 equals to 5. And the reason is because of congruency. So that triangle ABC is congruent to triangle DEC, right? Then the second portion is what? The second portion is to find X. But X, we need to use Pythagoras to solve for it, right? So we're going to say in triangle, this triangle, right? So it's going to be in triangle DEC, right? So in triangle DEC, what do we see? We see the fact that, so in triangle DEC, we're going to use Pythagoras. So we're going to start with the hypotenuse. The hypotenuse is the one that's opposite to the triangle, the 90 degrees. So we know the fact that we know for a fact that CE, that's what I wanted to say, we know that CE is going to be ECE squared is equals to what? Is equals to the two sides. So it's going to be equals to DC squared plus what? Plus DE squared. Substitute everything. We know the fact that this is 5 squared. CE is 5. Then DE is going to be X squared. Then this one is going to be 3 squared, right? Just solve it. Take the X to the other, take the 3 squared to the other side. So this is going to be 25 minus 9 is equals to X squared. Let me just put an arrow that I'm going to continue in this direction. Therefore, I know the fact that 25 minus 9 is going to give me what? Is going to give me 16. So X squared is going to be equals to 16. Then just put an arrow, meaning I'm continuing. Therefore, X is going to be equals to what? It's going to be equals to positive 4. And the reason why we don't use the negative because of length is always positive. I hope that made sense. So now what I want to talk about quadrilaterals, right? So it's your parallelogram, your rectangle, your square, your rhombus, and your kite. And the last one is a trapezium, right? So let's discuss each and one of them and look at its properties, because it's very important, because when you get to test, some diagrams might have properties of a parallelogram, rectangle, a rhombus, or any of the quadrilateral that I'm going to discuss. So it's very crucial for you to understand their properties so that it's very easy for you to answer questions. So the first one that I'm going to do is what is a parallelogram, right? So let's look at the summary. It says what? Well, let's just look at the diagram, right? We see the fact that in a parallelogram is that opposite what? Opposite sides are equal. So we see the fact that the opposite sides are equal to each other. Then one more thing is that the opposite sides are parallel to each other, right? So that's what you need to know, is that the opposite sides are equal and are also parallel to each other, right? Then what do we see? We see the fact that in a parallelogram, right, is that the opposite angles are what? Are equals to each other. Do you see that? That opposite angles are actually equals to each other. Then another thing that we see is that the diagonals, they intersect at this point here where I put a point. And what happens is that the opposite diagonals are equals to each other, right? So the opposite diagonals are equals to each other. So that's the properties of what? Of a parallelogram. So a parallelogram and a rectangle, right? What is the difference? The difference is that a parallelogram is slanted and a rectangle is straight, right? So I'm going to say there are differences after talking about the properties of a rectangle. So now let's move to the properties of what? Of a rectangle, right? So what do we see? We see the fact that in a rectangle is that opposite sides are what? Are also equal. So we see the fact that these two are equal to each other. And they also parallel. So opposite sides are also parallel to each other, right? Then after that, right, what do we see? We see the fact that the corners of a rectangle is equals to 90 degrees because of it's not slanted, right? It's straight, so it's 90 degrees. Then we see the fact that there is what? There is a intersection, right? So we see the fact that it's diagonal, so this AC, right, is equals to this AD, right? The diagonals are what? Are equals to each other. So if the diagonals are equals to each other at this point, it means the fact that all these diagonals are equals to each other. So all these 4 lines are equals to each other because of what? Because as I said that AC is equals to AB. Because there are, no, AC is equals to what? To B to DB. Because their diagonals are equals to each other. So just remember that. So now let's talk about the difference between a rectangle and a parallelogram, right? Is that with the rectangle is that we see the fact that the corner is 90 degrees, but with the parallelogram is that their corner is not 90 degrees, right? In the rectangle, all the corners, right, all the angles in the corners are equal to each other, but in a parallelogram, only the opposite angles are equal to each other. then in a rectangle is that all 4 of the diagonals are equals to each other, but in a parallelogram, the opposite diagonals are equals to each other, right? And in terms of the difference, that's it, right? So now let's move to what? Let's move to a rhombus. So even here, we're going to see the fact that a rhombus and a square have similarities, right? There's just slight differences. A rhombus is a square that is tilted. That is the difference, right? So let's first discuss the properties of a rhombus. We see the fact that all sides are equal of a rhombus. All sides are equal. Then opposite what? Opposite sides are parallel to each other. So this happens, right? So in a rhombus, what do we see? We see the fact that the diagonal, right, where they intersect, it creates a 90 degrees, right? And what we see again is that the opposite, right, the opposite sides are equals to each other. So this one is equals to this one. That's what we see, right? And what do we see? We see the fact that this diagonal, right, cuts the angle here at the corner. It bisects it, meaning this angle here and this angle is going to be equals to each other, and this angle here and this angles are going to be equals to each other, and also this 2 are going to be equals, and this 2 are going to be equal. So the diagonal cuts this angle equally, so it bisects it, doesn't it? And what do we see? We see the fact that now the opposite angles are also equals to each other. So the opposite angles are also equals to each other. So that is the properties of what? Of a rhombus. So now let's look at what? At properties of what? Properties of a square. So we know the fact that with the square, all sides are what? Are equals to each other, as you can see. And what happens is the opposite sides are parallel to each other too. Right? Then what do we see? We see the fact that a diagonal, it cuts it, right? Two diagonals, when they meet, they create a 90 degrees. The intersection creates a 90 degrees. And another thing that we see the fact that the diagonals are all equals to each other. All 4 diagonals are equals to each other. We also see the fact that the corner, because of it's not tilted, is equals to 90 degrees, right? And also the diagonals are going to cut it. The diagonals are going to cut that corner. The angles are going to be equals to each other, meaning this is going to be 45 and 45, 45 and 45, 45 and 45, 45 and 45. So that's what we see. Let me just look at it. Yes, that's what we see. So now let's talk about the difference, right? The difference between a rhombus and a square is that we see the fact that this one, the corners is 90, where with the rhombus is not equals to 90. We see the fact that in a square, all the diagonals, right? All 4 pieces of the diagonals, all 4 lines are equals to each other. But in a rhombus, only the opposite sides are equals to each other, right? Then we see the fact that, and that's the only difference that they have, right? So now let's move to another quadrilateral, right? So here we're going to talk about a kite, right? So a kite looks like this. So what do we see with the kite? We see the fact that these 2 are equals to each other. Opposite sides are equals to each other, like this, right? Then we're going to have a diagonal, right? In such a way where they intersect, where the 2 diagonals intersect, it creates a 90 degrees. And what happens is that this part is going to be equals to this part, but these 2 are not equals to each other. These 2 where I put dots, they're not equals to each other. And also in such a way, the fact that the diagonals here at top are going to bisect this angle, meaning these 2 angles are going to be equals to each other, and also the bottom angles are going to be equals to each other. So this is the properties of what? Of a kite. What I just said is properties of a kite, right? So now what we're going to discuss a trapezium. So with the trapezium, there's only one property that you need to remember, is that the opposite sides are what? Are parallel. That's it. Is that the opposite sides are parallel, and only this pair. Do you see the fact that this pair is parallel, this pair is parallel, and this pair is parallel? So now we're going to talk about an isosceles trapezium, where is what? Is that we see the fact that the 2 sides are equals to each other. That means that the opposite angles are going to be equals to each other. But the most important thing that you need to remember about a trapezium is what? is that opposite sides are what? Are parallel to each other. So welcome to two-dimensional problems, right? And terminology is very important here. We need to understand what is angles of elevation means, which is also known as angles of inclination, and also what is angle of depression. You understanding this is going to make this section very, very, very simple. So without just looking at the definition, I'm just going to draw a diagram so that you can understand, right? So if we have a diagram, let me erase that. So what is important is that if you have a horizontal line, because the angles are at reference to the horizontal line. If you have a horizontal line here, which in the situation could be the ground, it could be anything. If it's just the horizontal line, then there's either going to be an angle that's going up here, and this angle that's going up is the one that's called the angles of elevation, right? So this is going to be the angle of elevation. So angle of elevation, also known as the angle of inclination. So the one that is above the ground is the angle of which is elevation or inclination. Then the one that's in the bottom is going to be the angle of depression. So this is the angle of depression, which is this one. So now let's recap, right? Is that you have a horizontal line. The angle that's upwards is going to be the angle of inclination, right? And the angle that's downwards is going to be the angle of depression. That's it. That's what you need to know, right? So now with that said, let's start answering the question, right? So the first question, it says what? It says Mandla flies a kite on a 17 meters string at an inclination of 63. Do you see the fact that they said inclination, meaning your angle needs to go up? So we know the fact that if this is Mandla, let me just change my pen. If this is Mandla, right? This is Mandla, and this is the string, right? We know the fact that this is the string of the kite. So this is going to be the kite like this, and the string is 70 meters, right? So the angle here, right? The angle, so this is going to be the ground where Mandla is, and the angle here, which is the angle of inclination, because they say the string inclines, this inclination is 63. Do you see the fact that that's how we would know the fact that it's going up? Because if this is the ground and this is the string going up, this is going to be the angle, which is 63. Then we're going to draw a right angle triangle connecting the string and the ground like this, and this is going to be H, right? So now with that said, they tell us the fact that what is the height H of the kite above the ground, meaning we need to calculate this distance, right? So we know the fact that since it's like this is a right angle triangle, so we can use what? We can use trig ratios to solve this, right? So what are we given? We're given the angle, and we're also given the hypotenuse. Do you see that? So we're looking for what? We're looking for the opposite. So we're looking for opposite because that's the one that we're given. Then this is the hypotenuse because it's opposite to this square. So this is going to be the hypotenuse, right? So what is looking at the trig ratio? Let me just write them here. Sine theta is equals to opposite over hypotenuse. Then we know the fact that cos theta is equals to adjacent over hypotenuse. And the last one is 10. Theta is equals to opposite over adjacent, right? So looking at this is that we have what? We have opposite and hypotenuse. Which one is opposite and hypotenuse is sine? Do you see that? So we're going to use sine. So you're going to say sine. So for the first one, it's going to be sine theta is equals to opposite over hypotenuse. Let's write down the information. We know that theta is equals to 63 degrees. We know the fact that H opposite is equals to H, which is what we want, the height, then hypotenuse, right? So the hypotenuse is basically equals to what? Is equals to 17, right? So let's substitute. So when we substitute, it's going to be sine 63 is equals to opposite, which is 8, divided by what? Divided by 17. Cross multiply, this is the same as 17. sine 63 is equals to 8. Then punch this into the calculator. You're going to find the fact that your height is what? It's equals to 15,15, right, meters. So this is going to be the height. The distance between the ground and the kite is going to be 15,15 meters, right? So we sorted. So the second one says, if Mandla strain C4, right, stands directly, directly below the kite, meaning C4 is here. So C4 is here. So this is Mandla and this is C4, right? So directly, directly below the kite, which is going to be here. Then they say calculate the distance D, which is the distance between the two frames. So we're looking for this. So this is going to be D, right? So if we're looking for this, looking at the information that we're given the fact that this D is going to be adjacent, right? And this hypotenuse and this angle. So which one is adjacent and hypotenuse? Do you see the fact that it's cos? So number 2 is basically finding cos theta is equals to what? Is equals to adjacent divided by what? Divided by hypotenuse. So we know the fact that theta is going to be the same, which is 63. We know the fact that adjacent, which is A, is going to be equals to D, which is the distance that we want between Mandla and C4. Then we know the fact that hypotenuse is going to be 17, right? So substitute. So this is going to be the same as cos 63 is equals to D. Then this is going to be divided by 17. Then this is going to be 17 cos 63 is equals to D. Punch that into the calculator. We see the fact that the distance is going to be 7,72 meters is equals to D. So the distance between C4 and Mandla is basically 7,72 distance. So I hope that makes sense. So that's how you would solve this question. So now let's do example 2. It tells us the fact that ABCD is a trapezium, right? And they tell us the fact that AB is equals to 4 centimeters, CD is equals to 6 centimeters, BC is equals to 5 centimeters, and AD is equals to 5. And they tell us that the point E on the diagonal AC divides the diagonal such that AE is equals to 3 centimeters. And they tell us that BEC is equals to 90. Then we need to find this. So we need to sketch whatever information that they gave us. So we know the fact that there's a trapezium, and the trapezium looks like this, where the top part is small, the bottom part is big, right? So we know the fact that this is going to be A, B, C, D, right? So we know the fact that AB is equals to 4. So this is going to be 4, which is the small part. Then CD is equals to 6, which is the big part, right? And they tell us the fact that BC, right? So ABC. So meaning, if that's the case, this is going to be BC being here, meaning this is going to be C and this is going to be D, right? So we know the fact that BC is going to be 5. Then we know the fact that AD is going to be also 5. So they both equal to each other. Then they tell us the fact that point E is in a diagonal. What you call this? It's on the diagonal AC. So diagonal is the point between the opposite side, right? So this line is called a diagonal, right? See the diagonal AC. So point E is going to be a point here, which is going to be point E. And they tell us the fact that AE is equals to 3. So this point here is equals to 3. And they tell us the fact that angle what? Angle B, starting here, BE going down, right? So BEC is equals to 90. So if we connect this, right? So they tell us that this angle is equals to 90 degrees. So meaning also the side is going to be equals to 90 degrees. Then they want us to find the angle ABC. So they want us to find this angle. This angle ACBC. So this corner B, right? So what do we see? We see from the information that we're given is that we can actually find this angle first because we're given this and we're given this, and this is going to be the angle that's missing, right? We can find this. Then from there, we can use the information that we have to find this, this side. From finding this side, we can find this angle. I hope that makes sense. So we're going to do it bit by bit. So we're going to start with this one, right? So the one that has all the information. So I'm going to say in triangle A, B, E, right? So I'm just going to highlight it for you guys so that you can see what I'm talking about. So let me go back to my blue pen and now I'm highlight. So I'm talking about this triangle. Looking at this triangle first, right? Since it's a right angle triangle, right? So in that triangle, we're going to find this angle here, right? So we know the fact that looking at this angle, the information that we're given is this one, which is opposite. Do you see? This is going to be opposite. We're given opposite. And do you see the fact that we're given opposite to the triangle, to the square, which is this one, which is hypotenuse? Which one is opposite and hypotenuse? Do you see the fact that that's sine, right? So we're going to say sine. So it's going to be sine. And we're going to name this angle. We know the fact that this angle is what? It's A, B, E. So it's going to be A, B, E, right? And just to emphasize something, why we're looking for individual, we know the fact that the angle that we want, which is angle A, B, C, right, is basically the sum of these two angles. So it's the sum of this angle, which is going to be A, B, E, plus angle A, angle C, B, E. So that's why we're looking for them separately. I hope that makes sense. So now the first thing that we're doing is that we're looking for this one, right? So we know the fact that side AB, ABE is basically equals to opposite, which is going to be 3 divided by what? Divided by 4, right? So this is going to be the same as ABE x sine, right? So this is going to be what? This is going to be 3 over 4, right? So when we say 3 over 4, this is going to be the same as ABE is equals to what? Punch this into the calculator. You're going to get your answer as being what? As being 48.6 degrees, right? So we know the fact that this one is equals to that. Then now in triangle, and I'm just going to highlight it in green so that we can see what I'm talking about. We're going to look at this one, right? So we know the fact that in this one, we're looking for what? We're looking for this angle here. But do you see the fact that we only have one information? But what is nice is that, do you see the fact that BE is common? And this one has all sides. So we can use what? We can use Pythagoras, right, to find this side. Then after finding this side, we can use what? We can use the trig ratios to find this angle. So that's what we're going to do. So now we find what? We find a BE, right? So we know the fact that that is Pythagoras. So that's the same as taking the hypotenuse first. So it's going to be AB squared is equals to BE squared plus what? Plus AE squared. Substitute, we know the fact that AB is 4, right? Squared is equals to BE is what we want. Squared plus AE, which is AE is what? Is 3. So it's going to be 3 squared, right? So that's the same as 16 minus 9 is equals to BE squared, right? So what we know the fact that since it's BE squared, we know the fact that this is going to be the same as 7 is equals to BE squared. Squared on both sides, so it's going to be root 7 is equals to BE, right? So we know the fact that this side is going to be root 7. So since now we know the fact that that side is root 7, now we have two sides and we can find our angle, right? So now in triangle, the green one, which is going to be BE, let me say triangle here. So in triangle BEC, right? We know the fact that we're looking for what? We're looking for this angle. So what are we given? We know the fact that we have this and this, right? So what is this? This is adjacent and this is hypotenuse. So what is adjacent and hypotenuse? It's going to be cos, right? So here is going to be what? It's going to be cos and this is going to be the angle that we want, which is going to be CBE. So it's going to be CBE is equals to what? To adjacent over hypotenuse, right? So this is the same as cos CBE is equals to what? Is equals to adjacent is √7, then hypotenuse is what? Is 5, right? So this is the same as CBE is equals to what? Is equals to cos arc, right, of √7 divided by 5. Then when you punch that into the calculator, you're going to get the fact that your answer CBE is basically equals to what? Is equals to 58,1, right? But we know the fact that we're looking for this one. So therefore, we know the fact that A, B, C is equals to A, B, E plus C, B, E. Then we know this 2, which is going to be the same as 48,6 plus 58,1. And when we add them together, this is going to be 106,7 degrees. And that's how you would solve this question. So now we're going to do example 3. It says a given diagram shows a building of an unknown height, which is this height, right? Which the height is TB. We start at point B, which is point B is here. Then we walk 100 meters away from the building to point Q, which is this point here. Then they say, next we measure the angle of elevation. I keep on messing up this name, but this is the angle, meaning the angle that's above the ground, which is this angle, which is the same as angles of inclination, right? From the ground to the top of the building T, which is this one. So they tell us this is the angle, and they say that angle is that. Then they say that calculate the height of the building, so that we're looking for this. So looking at the information is that we have this angle, right? So this angle is given, and we also given this distance between the distance that you walked from the building, right? Which is going to be what? Which is going to be adjacent, right? So we know the fact that this and this is given. And so we have this angle and this side, and this is going to be opposite. So this is what? This is adjacent, and this is opposite, right? So which one has adjacent and opposite? Do you see the fact that the one that has adjacent and opposite is 10? So we're going to use 10 here, right? So here is going to be what? Is going to be 10. 10 theta is equals to opposite over what? Over adjacent. We know the fact that our theta angle is 38,7. And we know the fact that O is going to be equals to what? Opposite is H, which is what we want. Then we know the fact that adjacent is going to be what? It's going to be 100. So let's substitute. So it's going to be 10. Then it's going to be what? 38,7 is equals to what? It's going to be equals to H divided by 100, right? Then this is going to be the same as saying 100, 10, 38,7 is equals to H. Punch that into the calculator. You're going to find the fact that this is going to be what? This is going to be 80, because they say to the nearest, what? To the nearest meter. So it's going to be 80 meters is equals to H. So therefore, the height of the building is basically equals to 80 meters. I hope that makes sense. So now we're going to do example 4. It says a block of flats is 20 meters, right, away. So let me just change my pen first. So we say a block of flats is 20 meters away from the cell phone tower. So we see the fact that the distance between the cell phone tower and the block of flats is 20 meters, which is the road, right? Then they tell us the fact that someone stands at point B. So someone is standing here at point B. They measure that the angle from B to the top of the tower, which is point E, is to be 34 degrees. So this is the angle, which is the angle of what? Angle of elevation, right? Then they tell us the fact that they measure that the angle B, right, from the bottom of the tower, which is here at angle C, is 62, which is going to be what? The angle of depression, right? Then they say, what is the height of the cell phone tower to the nearest meters? So what do we want? We want this. the height of the cell phone tower. This is the entire height of the cell phone tower. Do you see the fact that the height of the cell phone tower is made out of two right-angled triangles, which is going to be the one with the angle of depression and the other one with the angle of elevation, right? So that's what we know. So what we're going to do is that let's break down this height. So we're looking for ED, and ED is made out of E and EC. We're looking for EC because that's the height of the tower, right? Which is made out of ED plus what? Plus DC. So we need to find this one and this one, right? And you see the fact that this is the one from the angle of elevation and the other one is the angle of depression, right? So that's what we're going to do. So I'm going to split them into two triangles. So we need to find from this triangle first, then the other one from the bottom triangle. So we're going to start with the one from the top triangle, which is the yellow one, right? So let's start. And that one, that's us finding ED, right? So finding ED, right? So in triangle what? Triangle B, A, D, right? So we know the fact that with that one is that we're given this angle. So we're looking for what? We're looking for this. We're looking for this. So this is going to be opposite. Do you see the fact that this and this are the same height, the same distance? So this is also 200 meters. So we're given also this side, right? So this side is what? We given opposite and we have this side, which is 200 meters, right? So we have that too. So which one is opposite and adjacent? Opposite and adjacent is 10, right? So opposite and adjacent is 10. So here is going to be the same as 10. Theta is equals to opposite over adjacent, right? So what is our angle? Our angle is 34. So this is going to be 10, 34. What is opposite? Opposite is what we're looking for, which is ED, right? Divided by adjacent, which is 200, right? So this is going to be the same as saying 200, 10, 34 is equals to ED, right? So ED is going to be equals to what? It's going to be equals to 135 meters, right? Is equals to ED. So therefore, we know the fact that ED is equals to that, right? So now we're done finding ED. So now finding the second portion, which is finding DC, right? So finding DC. So finding DC, we know the fact that we given this angle of depression, which is 60 what? 62. Then this angle side, which is this one, right? So do you see the fact that this is what? This is the same as what? This is adjacent and this one is opposite. So this is also 10, right? Because that is opposite and adjacent. So this is going to be what? In triangle BDC, right? So we know the fact that we're still looking for 10. Theta is equals to what? Is equals to opposite over adjacent. In our case, our angle is 62, so it's going to be 10. 62 is equals to opposite, which is opposite is going to be what we're looking for, which is ED. So it's going to be DC, divided by what? Divided by adjacent, which is going to be 200. So this is going to be the same as saying 200, 10, 62, right? So when you say 200, 10, 62, it's going to be equals to what? It's going to be equals to DC, right? So we know the fact that DC is going to be equals to what? It's going to be CD or DEC is going to be equals to what? It's going to be equals to 376 meters, right? So this is going to be DC. But we're looking for the entire length of the tower, right? So we know the fact that the entire length of the tower is basically going to be equals to E. C is going to be equals to what? It's going to be equals to ED plus DC, right? So therefore, EC is equals to what? Is equals to 135 plus 376. Add them together, we're going to see the fact that the length of the tower is basically equals to 511 meters. So the length of this whole tower is equals to 511 meters long. Hope that makes sense. So now we're going to do example 5. It says Mr. Nkosi has a garage at his house and decided to add a corrugated iron roof to the side of the garage. The garage is 4 meters, what you call is 4 meters high. So we see the fact that this whole thing is 4 meters high, meaning also this whole portion is going to be 4 meters high. Hope that makes sense, right? And his sheet of roof is 5 meters. So we see the fact that the sheet of the roof is 5 meters long. Then they say the fact that if the angle of the roof is 5 degrees, so this is the angle, right, is 5 degrees, how high must the building of D, what you call this, BD, right? So how high must he build the wall BD? So we're looking for this, right? We're looking for this wall. Then they say the fact that give your answer in 1 decimal place. So we're looking for this portion. Let me just highlight it so you can see it. We're looking for this, right? Since we're looking for this, we see the fact that to get this, right? Do you see from here is that to get this portion is that we need to separate it from here. So to get this portion, right, is that we need to minus the small one. You first need to minus the small one. So we're going to basically find the small one, minus it by 4. Then we're going to get what is this section. I hope that makes sense, right? So to find this BD is going to be equals to this. Let me take my pen. This and this portion are equal, right? So that we know the fact that the whole wall, we know the fact that the following, right? We know the fact that the whole section, and let me just say the, what you call this, the house call, right? So we're going to say the whole 4 meters, right? Yes, the whole 4 meters is made out of what? It's made out of the small portion, which is CA, right? Plus what? Plus BD. Because of this and this are the same thing. Hope that makes sense. So for us to find what is this, is that we need to basically find CA and subtract it here. So this is going to be the same as saying 4 centimeters, right? Or 4 meters, sorry. 4 meters minus CA is going to be equals to BD. So that's how we can find BD. Hope that makes sense. So from that is that we need to find this side. But the nice thing is that we know the fact that we're given enough information to find this side, right? So we know the fact that this side is what? This is going to be opposite, right? So this is opposite. The CA is opposite. Then we see the fact that there is a 90 here. So this is going to be hypotenuse, right? So this 5 meters is hypotenuse. So which one is opposite and hypotenuse? Let's go back. Do you see the fact that that is sine? So we're going to have sine. So we know the fact that sine beta is basically equals to opposite over hypotenuse, right? So we know the fact that sine, the angle is 5, so it's going to be 5 degrees is equals to opposite is what we're looking for, which is CA. So we can subtract it by the 4 divided by what? Hypotenuse, which is going to be 5, right? So take the 5 to the other side. So this is going to be 5 sine 5 degrees is equals to CA, right? So punch that into the calculator. You're going to see the fact that this is going to be 0.4, right? It's equals to CA. So now we know the fact that CA is equals to 0.4. So now we know the fact that, therefore, we know the fact that BD is basically equals to 4 minus CA. But we know that CA is 0.4. So we know the fact that BD is equals to 4 minus 0.4, right? Which is going to be equals to BD is equals to what? To 3.6 meters. And that's how you would solve this question.